So my name is Jason Smith, but you can call me Jay. I'm a customer engineer here at Google Cloud. I joined Google Cloud about 6.5 years ago. My kind of specialty is application ecosystem. In Google terms, that means everything containers, or as I like to call it, I specialize in container and container accessories. Let's get to the agenda. So we're going to talk a little bit about what I call the perfect tool, the role of Kubernetes, often cited as Kates, in AIML. We'll see a quick demo and then we'll do what I call accelerator news. Stay tuned because that's going to be very exciting. You might be wondering, what is accelerator news? Well, you'll find out. So, we are all looking for the best tools for the job. This is just a universal truth. And it's, it's not just tech. It's like if I am trying to do some woodworking and I have a screw, a hammer's probably not going to be as helpful, nor would a wrench be. If I'm trying to cook a cake, or excuse me, bake a cake, I could use like a pottery kiln, but an oven would probably be a bit more effective because there's more knobs and such. Well, when we're talking about machine learning, there really isn't the best tool for it. It doesn't exist. And you might be thinking, okay, well, why did I sign up for this talk if you're telling me that there's not a good best tool? Well, I would say slow your roll a little bit. It's not so much that there aren't tools, it's just that there's no best singular tool for machine learning. I would be lying to you if I said, go and grab this thing and it is going to solve all of your problems for machine learning. That just doesn't exist. What I always tell people to think about it in the terms of a toolbox. So when you have a toolbox, you have multiple tools, right? You don't have one tool. You're not going to try to build a house just by using anything, just by using, say, a wrench. You need a whole set of tools to build a house. Some probably industrial size, some probably smaller. It's the same thing with machine learning or any kind of tech. You need multiple tools to build what it is you want to build. So it's not about seeking the best tool, but seeking the best platform and components. A platform is the baseline, the foundation. It's what allows you to build on top of it, to build the entire ecosystem that you need, the entire framework that you need. And then you build that with various components. So Kubernetes is a platform for building platforms. So I bring this up because I think a lot of misconception exists about Kubernetes. People think Kubernetes, microservices, apps, all that stuff. Kubernetes isn't the end game. What Kubernetes does is give you the ability to build more on top of it. So it gives you the primitives that you need to more successfully build and manage long term these platforms. As of today, Kubernetes is a de facto platform for running containers. There were a ton of them back in the day. Docker came out around 2013 or early 2013. People started thinking it was great. It was great. Containers at that point in time, and still to this day, were revolutionary. They were better than VMs for a lot of use cases. People were trying to figure out, well, how do we manage that at scale when we're managing hundreds, if not thousands of them? Google, with our experience running Borg internally since around 2004, then kind of making it more common in 2006, we said, hey, we kind of solved this container issue, or in a lot of ways internally. We want to go ahead and share our learnings by creating an open source platform called Kubernetes, and give it to the world. And sure enough, Kubernetes is like the number one platform for containers, bar none. There are others, but Kubernetes is definitely ahead. And what it does really well is it abstracts away the infrastructure. So making it easy to build a platform using the primitives such as networking, storage, servers, memory, CPU, etc. It makes it super easy with its declarative API to build on top of that. So you can build a lot of platform. But Kubernetes is not a magic bullet. I always love this Dilbert cartoon because I think it exoner or it exemplifies. There we go. That's a word. It exemplifies exactly what it is that we see a lot of people do in tech. A lot of people will see the next best solution, the next big thing, and be like, oh, well, why don't we just use this? let's move all of our clouds, all of our apps to the cloud and containerize it, microservices, Kubernetes. It's like, no, just saying tech words doesn't solve anything. So that's kind of where we are now. And I always say Kubernetes isn't a magic bullet. You can't just install Kubernetes and say, hey, I solved all my problems. Trust me, I've seen a lot of people who just essentially lift and shift. They take the exact same architecture, containerize their VMs, deploy it on Kubernetes, and then they wonder why they're not getting the full benefit of the cloud. It's like, well, you didn't really modernize your application. You just kind of moved it from point A to point B. That being said, Kubernetes offers a ton of benefit. One, it's portable, right? Once, run everywhere. It uses the standard Docker OCI container runtime, and it uses open standards. Kubernetes is open source. It isn't even owned by a company. It's owned by CNCF, the Cloud Native Compute Foundation, which is open source foundation. It's underneath the Linux Foundation. It essentially is a nonprofit that owns a bunch of projects, including Kubernetes, but some others like Prometheus. And it essentially guarantees like kind of a neutral ground that owns those open source license. And it also helps build the ecosystem and kind of encourages companies and individuals to come together and develop. So because of that, it's open source, open standard. Kubernetes is Kubernetes, no matter where you have it deployed. So good environment. Also, you have the right framework. So, what does that mean? Well, there are a number of Kubernetes frameworks, or excuse me, machine learning frameworks out there that can run on Kubernetes. This is by no means an extensive list, but these are some of the most popular that I see out there, such as Beam, Spark, Ray, Dask, so on and so forth. These are very standard open source frameworks. They're used in corporations of all sizes. There are companies like, say, Databricks, whose main business is all related to Spark and whatnot. So, you choose the framework that makes the most sense for your workflow and your business, and you can usually deploy it just fine on Kubernetes. Almost all of these frameworks, I'm sure there's some niche ones that have come out that aren't supporting of Kubernetes, but almost all of these will run on top of Kubernetes and have like a Helm chart or something containerized. Of course, you can fine tune it for performance because you're able to use different machine types. You can mix and match node pools, so I can have a smaller machine type on a node pool for smaller workloads, and then a larger machine type on another node pool for larger workloads. I can actually create a node pool that's only has GPUs that I can either, just delete or scale down when I don't need them as much for ML workloads. You're able to fine tune the performance and scale the platform as needed for your use case. And then that also allows you to pay for what you need. So you can change the utilization rates. You can figure out ways to save by auto scaling up and down. So save based on the traffic coming to the workload. But then also it reduces operational costs. Like there's just less for you to handle. If you have one platform, rather than trying to learn like 30 different things just to run your business, you're limiting it and making it easier to manage and maintain. And while there's not a list price to that, it is still in the total cost of ownership tends to be better, just generally speaking. So this is why Kubernetes, I think, won the open source war when it comes to containers. In fact, it is the second highest, or excuse me, second fastest growing open source project after Linux of all time. So, this is why it's doing so well. So, I also want to talk about, AI. This is Google Kubernetes Engine for AI. There are a few things here that are unique to Google Kubernetes Engine, such as TPU and fleet team management, but I want to make it incredibly clear that a lot of this stuff is universal to any Kubernetes cluster. In fact, I would say 90, maybe 95% of stuff is, so don't obsess over the fact that it's Kubernetes Engine. I'm just pointing out that this is a common pattern that I see in my line of work. So what we see is we have, the infrastructure. That's the storage, that's the networking, that's the machine types, that's CPU, GPU, TPU, which we'll talk about later. You might be wondering, well, what's a TPU? But then, of course, on top of that, you install the Kubernetes, which has the auto scaling, provisionings, job queuing, all these different primitives. If you're using GK Enterprise, you get something called fleet and team management. And then on top of that, you install the frameworks, so something like Cube, Ray, Kubeflow, and then you install like the notebooks, which is Jupyter Notebooks, which is incredibly common for data scientists. Q is a relatively new open source project. It is part of CNCF. It's part of one of the Kubernetes SIGs, I should say. And it is essentially a way to solve the queuing problem with Kubernetes, specifically as it relates to machine learning. The reality is that Kubernetes historically has been, for the first 10 years of its life, an application first platform. Most what people would deploy on Kubernetes is our applications. In fact, half of the internet runs on Kubernetes today. With this new like paradigm shift that we're going to expect to see for at least the next decade, we're going to see more people doing machine learning, and that kind of requires us to think of things a little bit differently than how we thought of apps. So this resulted in people creating queue, which makes it easier to execute workloads sequentially. And here's kind of a quick architecture for nerds like me. You're welcome to like pause on this and read it, or you can actually go to the website for Q. Just Google that, and you will find a link to their GitHub, which has the spec. I also want to talk about Ray because, as I see now, Ray is easily the most popular distributed learning framework out there for Kubernetes. That could change in time. I hope we get more competitors. I think competition keeps us on our toes, but also kind of keeps us, the community, on our toes, not Google in particular, but everybody. And it also encourage like, I guess innovation by trying to do things better or find ways to solve problems, so on and so forth. But that being said, Ray is a great program and it's incredibly popular. So you can see how it's like the entire the machine learning framework is kind of built on top of Ray. Ray is popular because it's cloud agnostic. It can literally run on any cloud. It is in there. It runs on top of Kubernetes, so anywhere you can host Kubernetes. And it is based on Python, which is the premier language for data scientists doing machine learning. It comes in multiple components, so you have the Ray core, but then you have additional libraries. It has Python first. And here's kind of a little bit of a quick TLDR on what it offers. So it's Python first, open source, simple and flexible API, very easy to use. You can use a lot of the accelerators such as GPUs, CPUs, TPUs, and of course it leverages Kubernetes scaling. It also has a bunch of different AI libraries. So Ray is a bunch of different components that make up Ray, such as the Ray Train, Ray Tune. And as you can see, it can integrate with other platforms such as TensorFlow for training, or Delta Lake for data pre-processing, MLflow for tooling, Gradio for serving. So you have a lot of these options that it can extend to, and it just makes it easier to manage that. As you can see, platform engineers love the portability, they love the OSS nature, it's intuitive, and it integrates with existing ecosystems, so that's why ML engineers love it. I want to talk a little bit, setting the stage for the demo you're about to see. If you go to, you'll see Customize here. You can actually just Google Customize. I know I'm cutting it off a little bit here, but Customize is an open source Kubernetes SIG project. It's essentially a config templating tool. So it's very similar to Helm, whereas Helm's more of a packaging tool. This templates, and what's nice about that is that what we typically see with Helm charts is as they get bigger and bigger and bigger and bigger over time, and people, join and leave teams, they just become very unruly to manage, and it becomes like a Jenga tower where if you accidentally pull like the wrong block, all of a sudden everything collapses. Templating makes it a little easier to extend by allowing you to set up resources as deployments, config maps, and it essentially operates on an overlay framework, and then you use customize.yaml to declare that template. And I'll show you a little bit about how that works, but I would also encourage you to read more about it if you're not using it today. And then, of course, we have to bring in Pulumi because Pulumi is amazing. Pulumi uses Python and other languages, but for the purposes of machine learning, since data scientists, machine learning engineers use Python almost exclusively. I mean, yes, there are other languages like R and Julia, and they are growing in popularity, and they are great at what they do. Python is still kind of the standard. Pulumi allows you to declare resources using Python as Python objects, so it's way less disruptive than other infrastructure as code platforms because it just allows you to use the skills you already have. And then of course we're going to deploy on top of Google Cloud using Kubernetes to have an amazing machine learning experience. So why don't we just go straight to the demo? Talk is one thing, but we'll go into the demo here. So what I'm going to do here is, here's what the end product's going to look like, but we will look at some code first. So here is my Python code. As you can see, very standard Python code. I'm importing libraries, Pulumi libraries. I am setting some environment variables. There's like a stack.yaml file, or it's Pulumi dot whatever you name your stack.yaml. You've probably seen in other demos that allows you to set environment variables, and I'm declaring them here as Python variables. And then here I'm actually creating a Kubernetes cluster. As you can see, I'm setting some variables here, such as the workload pool service account, which is project.sfc.id.goog. I'm turning on the CSI driver, secure boot, all this stuff, just declaring it like I would any other Python thing. And I'm creating a node pool specifically for the machine learning. So we're going to have a 20 gig disk. We're going to have 2 local SSDs. We're going to be using NVIDIA L4s, two count with the latest driver. I'm installing the driver. I have very permissive OAuth scopes here. You can read the documentation to find more or less permissive. Min node, max node count. I'm declaring all this stuff. I'm getting the Kubernetes object, or excuse me, the Kubernetes config here so that I am able to connect. Here is the config being created. And then, of course, I use this to declare or deploy the kuberay application, which is a customized file, and I'm using the kube config provider. You want to look at the customize real quick, I'll show you that here we have where it's declared. So it's looking for resources in the CRD file, the RBAC file, YAML. And then, of course, we are using certain images. So I already executed it, as you can see here. So yeah, you can see here that I've already executed some of the code, or I already executed Pulumi up because it takes like 20 minutes to complete, so I didn't want to force anybody to sit here and run, but as you can see, it did successfully complete. I come over here, we have the kuberay cluster. You can see that I'm using version 1.29. I've set my network, kubedns, we have shielded nodes, we have that workspace identity right there. I'll go up to my node pool real quick, and actually let me make this a little bigger so you can see it. GPU node pool, 2 nodes. We have 2 NVIDIA L4s with 20 gig boot disks, 2 of them. So all the stuff I showed you was declared. And then, of course, you can see that kuberay is running right here. It was deployed in the race system namespace. So look, it was just that easy to do it. One Python file, I was able to build my entire platform. And just to show you that this is like a new cluster, you should be able to see roughly around what time it was created. Okay, it's not showing up here, but it was created like right before this recording. So yeah, it is just that easy. Bear with me 1 second as as I get back to the presentation. So I want to talk a little bit about Google and its AI. And we've been in AI for a while. Our technology, our whole memo or our whole mantra, the reason we created our mission statement is to organize and collect all the data in the world. And the way you do that, or the way you can help do that efficiently, is with AI. So we've done a lot with AI. We have 3,000 researchers, over 3,000 researchers. We've done several publications because we want to share what we've learned. Things like responsible AI. If we're going to have AI, we as a society, not just Google, we need to be responsible in how we use it and how we train it. So we do share a lot of those ideas with people, and we try to uphold high scientific standards. We did actually invent the transformer. So the T in GPT, it stands for transformer. Google created that in 2017. I say all this to show, one, that we are in the AI game, but more importantly, I do want to highlight one thing that's really cool that you can do with GKE specifically is the TPU. Google Cloud has a product called the TPU. It's the Tensor Processing Unit. Basically, it's similar to a GPU, but it's more special purpose. So with GPU, that's graphic processing unit. So that was created for the purpose of processing like images for video games or video rendering, stuff like that. It just was a happy accident that it was also good for machine learning. Google internally created TPUs, tensor processing units, which are processing units specifically for machine learning. So they run more efficiently, they can perform more flops and get more pretty much just get you the answer quicker because it's more efficient the way it's developed. And also, you can attach it to a GKE cluster. So if you want to use TPUs instead of GPUs, you can. GPUs are always going to be popular, and maybe you want to standardize across their platform what you want to use, but TPUs are great too. Apple actually just released a white paper about a few weeks ago where they talk about how they trained Apple Intelligence on TPUs on at Google. So, it's pretty cool. I understand that not everybody wants to use it, but if we're going to be talking about Kubernetes and AI, I feel like it's important to actually bring up the option of TPUs and why you might want to use GKE. But I also acknowledge that you might want to continue using a standard GPU that you can use across all cloud providers, including in your own office. Or in your own data center. So, those neither option is better or worse, but I would recommend, taking a look at TPUs. Here's some of the nerd information here about how it performs compared to other things. And then a little bit of a kind of a quick chart to see things. So, cloud TPU pods can go all the way to supercomputer level, and you might say, well, Jay, I don't need a supercomputer. I'm not trying to do that kind of stuff. And I'd be like, that's cool. So you could just use edge TPUs, TPU slices. But as you can see, there are some GPUs that can also do that as well. So you do have a few options out there. I do want to point out that you can start with Google Cloud for just using your at gmail.com address. You can sign up. You don't have to use a credit card. You'll get an automatic $300 credit. Basically, once that runs out, your project is stopped. But then we also have a free tier, so you can go to cloud.google.com to learn about the free tier for all the products. And that it's good for experimenting. Obviously, when you get past the experimental phase, you're going to start incurring costs. But it does give you a little bit of a leeway to do some experimentation. Speaking about costs, if you do my demo, please be sure to do Pulumi down. You don't want to keep everything running and get a bill and have to figure out who's going to pay for it later. But that is my talk, and I thank you all for your time.